Today we are at 2020 and we are facing many threats for human race since a COVID pandemic through the increase in deforestation and increase of temperature on the earth. So how can we reduce the impact of these threats in our planet? The climate change forces migration in Latin America as this is one of the regions more vulnerable to natural disasters and climate change. We have seen drought, floods, who have left more than 20 million people displaced and needs to move from the rivers to higher places and also crowded places. So, according to UN, United Nations, the climate change is more lethal than COVID in the long place. So, how we can help to reduce it? The energy we spend in our homes impact the advance of the climate change. And we know that's not all the impact of the climate change. But we can contribute by knowing how do we use the energy and optimizing their usage. How do we know how many and how we are spending the energy or consuming the water? Well, the information that we got daily in our electric bill or water bill gives only the total usage at the end of the month. So we can't know how do we spend in the daily or even in hourly basis. So besides the higher contributors in CO2 in the earth are the motor vehicle fuel and fuels indirect that are being managed by other uh, industries. Look at that. Housing is the second area of impact and also the energy consumption in the enterprises. So, if we can manage to reduce the waste in water and energy, we can make a significant contribution to reduce the climate change. So the option is to do a more efficient usage of renewable energy and also identifying what components at what behaviors that do we have. It provides the highest consumptions. But the consumption it not only depends on when we power an house appliance. The impact for the same amount of energy is different if it comes from coal, nuclear plants, hydraulic, or clean energies like solar or wind. And we don't know that information in a daily basis, but some others know. Also happens with water costs. If it requires pumps, the cost of the usage of water could be higher. And also the source of the water could produce more impact in the climate change. If we are going to measure our contribution, we not only need to know how do we consume, we need to correlate this information with the source of that energy or the source of that resources that we are using. So our project focuses on what if we could measure our consumption at home and at work in a cost effective way? Because house metering appliances are not affordable for most of the people in third world countries or even the poorest people on the earth. So how we can massify this knowledge in a cost effective way, and also how we translate this consumption in a reliable way that everyone that took a measure could be reliable and the same level of reliability that everyone else. So all the people that contributes to reduce the carbon footprint can get a way to get recognized by their efforts. So we started seeing that all houses, even the poorest, have a single entrance for the energy or water or gas. In the case of energy, a circuit breaker with several circuits derived for several devices in the house. And usually we have a main breakers taking a main control and other breakers for the other circuits in the house. And also for water or gas, we have derivations of the connections. So if we could put a meter on the common entrance for all the aspects, we could measure not only the consumption, but also the variations in the consumptions. So we can get for these deltas of consumption to identify consumption patterns. For energy, for example, we consider the use of non invasive sensors. So we do not need to plug and unplug all the electric devices. We could measure in parallel without affecting the security infrastructure in the house, but putting the device inside the electrical panel. And that information to be sent through internet to a collecting platform that can read all the mapping from all houses. In order to send the information to internet, we can use the home router, or in the case that people that can't have internet connection, we could use mobile cell tethering to do the connection. The information is sent to through internet to Watson IoT, and then a Node-RED application can process the information and do the analysis to the historical data. The device considered has a single design in order to do a good effective consumption and uses only a single energy sensor and optionally a temperature and humidity sensor that we can use later to correlate the information about temperature and identify if the expenditure of energy is related to freezing or heating, and also identify variations in the climate factors. For single power lines, we can use the Node MCU 8266 module. And for multiple analog lines, we need to switch to Arduino Nano because we need to have more than a single analog read. So here is the finished device that we use for testing. We also consider relays to do the home switching and also to do and control the expense in the daily or weekly way, and be able later to design a quota of usage in the house in order to give an advice for the people in the house about the consumption. Once the device is installed, first we need to register the device, both in Watson IoT and in blockchain. First, We need to configure the Wi-Fi in the device. So the device came with a pre-configured hotspot on a private network. So we can use our cell phone to connect to this Wi-Fi. The user then registered the SSID, Wi-Fi ID, and the password in order for the device to connect to sorry to an to internet access. If we only have the cell phone, then the SSID will be the Wi-Fi for tethering in the cell phone. The ID sent for the device in order to identify his consumptions and also for registering the transactions in a blockchain network will be a combination of the device MAC address and the registered name for the device. So the variables measured depends on the sensors adapted to the device. In the example, we use power and current using a current sensor and humidity and temperature. And we are able to identify some environmental factor like the sensed temperature based in humidity. Then the next step is to register the Watson IoT network. So each one of the home meters are registered, and there we can process and see the information that we collected from the device. And then this information is sent to Node-RED app in order to get a personal meter for each one of the people registered in the network. So we got measurements of environmental, like temperature and humidity, energy, like power and historical consumption, and also the calculation of the carbon footprint based on the equivalencies on energy or water consumption. So we could check based on the ID of the person and each one of the devices if the people manages more than one device and get the CO2 equivalency in consumption. So this is the state we reach with our project. We need to develop more aspects. So our next steps for this project is to develop additional capabilities for home meter IoT device like the remote control of energy usages and activation in the house, and to enable the device mesh network to be able to communicate through several devices in the house to collect several environmental and consumption in the case of industries or companies. In the cloud application, we need to develop also the analytics for get the historical decrease of consumption and determine energy efficiencies in correlation with early power and water costs. And to integrate more actors in our blockchain network in order to get reliable sources for the CO2 equivalencies to calculate the carbon footprint for our network and to get the consumption for real home appliances or industry appliances to give more intelligence to our calculation. And finally, get a funding for financial compensation of that CO2 contribution in order to get benefits in the network to the aspects that get in a network.